this for. Sweet. All right. Let me share my screen up. Um, Work, and here we go. All right, so I kind of mocked up the two fixtures that you had sent me, right? So looking at like a chandelier like this and a monopoint fixture like this. I also have a basic 2D symbol here for like a symbol type. And all of this requires that we basically establish our 0, 0 point. We have to build everything off of that because really what we're going to do is combine a whole bunch of different scripts together. Some of this is going to require a little bit of coding. Um, because we do want to make these things as parametric as possible. And an example of this would be, so this light fixture here, this example, I have it mocked up with the actual pendant hanging height as well. And I'll just kind of show this as a for instance. But if I were to pull this over to here and at 0, 0, so I'm making sure that everything's kind of centered off of that. And then I go to File, Libraries and Objects, Save Selection as Object. We'll say test one pendant and OK. And now when I place that pendant, it looks fine. It works great. Um, but the downside is if this, let's say, needs to become a taller ceiling and I stretch this, it stretches and distorts, right? And we don't want that. We want to be able to resize the pendant and also have a hang height to make this thing truly parametric. The other thing that we have on that object is, let me go back into this guy and look at it. I've added a box, the junction box. We can like create parameters to turn these things on and off really easily. So that's what I want to walk through is like how do we make this hang height adjustable, make the lamp resizable, and make this box something that we can turn on and off. Okay, that's our goal with this one. I'm going to go ahead and delete that geometry. And by the way, this geometry, I just used shells. They're all revolved shells for all of these fixtures, in case you're wondering how I got the geometry. It also looks like this is not quite centered. So we'll adjust that. Okay, that's better. All right, so the first thing I'm going to do is drag this fixture over to here to the center point. Oops, we'll isolate this guy out in 3D, right? And then the other thing that I want to make sure is that everything is also off of the right height on the z-axis. So there's my origin on the z-axis. Um, oh, I'm grabbing that box too. I want to know like how far off of the ceiling this pendant's going to hang. So I'm going to drag this down to here. We'll go ahead and put these down there as well for now, but I'm going to move them off to the side. We'll say 5 feet. So we'll go back to our floor plan view. Oh, there's the ceiling box and the hang height. Okay, so now I'm going to grab, actually, let's do a screenshot first. This is going to be my thumbnail. It's easiest to get a screenshot ahead of time, so I'm just going to go and say that's my thumbnail for what the final object's going to look like. And I'm going to go to File, Libraries and Objects, Save Selection as Object. I'm going to create a new folder, and we'll call this Pendant 1 and change details, set preview, and that's where that screenshot is useful because now I've got that thumbnail in there. I don't have to worry about it. And then we're going to say, okay, uh, first thing I'm going to do is place that into my floor plan. So now I have the base object to work from. Next, I'm going to move this out of the way, and I'm going to move these guys up that 5 feet that I had offset. Let's go ahead and look at these in 3D. Again, making sure that we are deliberate about where we're aligning these from. Right, so that 0, 0 point really is going to be at the ceiling. So I probably want this box, and I don't know what the actual design of that ceiling piece would be. I just kind of threw something in here. So that'll be the ceiling box and the housing, the junction box and the housing. Let's go ahead and go back to our floor plan view. And just so we can like put this together, I'm going to put this down 5 feet as well. We'll make it as parametric as possible. Now I'm going to take this piece, go to File, Libraries and Objects, Save Selection as Object, um, Working Lights, Pendant Box 1. Okay, and I don't worry about the preview of this one. This is just going to be a placeholder. I'm going to copy and paste all of this stuff together. And then I'm going to take this and pull it up 5 feet. And I know that this is in the right spot vertically based on the other one. I'm going to go to File, Libraries and Objects, Save Selection as Object, and we'll call this one Junction Box. Um, can't have two library parts of the same name. Okay, so now I have those three pieces. While we're here, let's go ahead and throw the 2D symbol in here as well. So I'm going to take this stuff and go to File, Libraries and Objects, Save Selection as Object, and put it in the same folder and save. All right, so far it's as simple as just saving this stuff. Um, let's go ahead and just so we can, this doesn't really have any bearing on it, just so we can kind of see all of this stuff together. I'm going to now select all four of those parts, and we're going to go to File, Libraries and Objects, and Open Object. It's going to let me know that I have four objects selected, and I'm going to open all four of these. So these four tabs here, 2D symbol, I can see that's that symbol. The pendant, that's the preview one. So this is what I'm going to call my main object I'm going to build off of. If we look at this in 3D, I know that the A, B, and Z, Z, Y, Z, X, these are the X, Y, Z parameters. So that's this size, and that height. Obviously, I was not very precise in my modeling, otherwise these would all be the same. But that's fine. We want to keep these things resizable. I want to next put in my pendant box. Let's go ahead and check that. So that's this ceiling piece. I'm going to go to the 3D script here. The mul commands, MUL, those are the resize commands. So I do want the mul commands in the main object, but I don't want them in any of the other parts because I don't want those to resize with the main pendant. So I'm going to eliminate the mul commands. The add commands are because it tries to push everything into the plus plus quadrant. And I want this thing centered on 0, 0 where I saved it. So I'm also going to eliminate the add commands. Now, because I used shells, the script on this part is going to be really, really minimal. This is the 3D script that defines this appearance. So I'm going to hit Command A and copy this. And now when I go back to my main pendant, we'll go to the 3D script here. I want to keep the mul commands, but I want to eliminate the add command because I don't want to push this up. I want this to align. Okay. So now if I want to put a note, I can add an exclamation mark and I can say that this is my pendant script, just so I can kind of keep track of where everything's at. And I'll paste in my ceiling box script. And then we'll copy and paste that in here. So now I should see that box in the ceiling. Oh, you know what? It's because it's actually embedded in the fixture. So we have to create a hang height parameter now. So I want to be able to create like what the distance of this pendant is. So under my parameters, I'm going to create a variable. This variable can be whatever we want as long as it starts with a letter. I'm just going to call this HH for hanging height. It's a distance parameter. I'm going to say hanging height. And let's say that the default hanging height is 2 feet. Okay. Now under the 3D script, I create an add command. And everything after that add command is what's going to be affected. So that's why the box here is above the pendant here. So this is the big script is that whole pendant geometry at the bottom. So here I'm going to put add Z negative HH. So it's going to shift that down HH. So there's the ceiling script at the top, the ceiling box, and here is the pendant. If I go to my parameters just to check this, I can say that this is 1 foot, and it's going to shrink that down to 1 foot. Um, I'm going to keep the AB and ZZYZX. That's going to resize this piece, the pendant itself. So if I were to say that this is 6 feet by 6 feet, then it becomes, but it's only resizing this piece because that's all that has an add command. So we'll set that back to 3 feet by 3 feet. Okay. Now I want to have that hanging rod or cable or whatever it is that connects these two. To do that, I'm going to come into the 3D script. And below this, I do want the cable to shift down with this because it was all saved from 0, 0. So I'm going to add one line of script here that says CYLIND for cylinder. And I'm gonna guess this wrong because it's radius and then height or height and then radius, and I can never remember which. So we're gonna say that this is, let's say that it's 1/4 inch, comma, HH. And I guess wrong. So it's height, HH, and then 1/4 inch, right? So now I have that connecting rod, and I realize that here in the thumbnail, it's probably kind of hard to see. But in elevation, you can see that connecting rod. And because it's all pulling from that HH parameter, if the thing gets taller, so if I say that this is a 10-foot hanging height, right, that cylinder stretches with it. If there was ever any reason for that diameter to be adjustable, you could create a parameter, a variable for this as well. We're just going to say that this is a fixed radius on that. Okay. Um, so now if we have that junction box, and Richie, this is something that you were asking about, how do we show that junction box or give options to show that junction box? So I'm going to come back up to the top here and create another comment. And we're going to call this junction box here. And we'll go to the JBox script here. The 3D script, again, we're going to eliminate the mul and add commands. And we're going to grab all of this and copy that out. We're going to go back into our main pendant object here, and we're going to paste that in here. Now I see that junction box populate up here. Um, there are ways that we actually really easily we can turn that junction box on and off in the script as well. So if we come into the parameters list here, I can add a new parameter, and let's just call that JB for junction box. And this is going to be I believe it's a Boolean function. It's the little X box on the list of parameter types. So the different variable types you can have are like dimensions, angles, integers, attributes. All the different attributes have their own. I'm going to use this X option here, and that's just an on-off switch. It's binary, so on is 1, off is 0. So I'm going to say JBox is going to be the name. That's just what's going to show up in the object settings. Um, and we're going to leave it off by default. So in my script now, I go back to 3D and I say if JB equals 1, then we're going to do everything that I pasted in here, else and if. So it's an if-then statement. If that parameter equals 1, then we're going to do this. If it doesn't equal 1, the only other option is 0. So else and if. Does that kind of make sense? Okay. And then we can check that here. So the junction box is off, and we can turn it back on. Okay. Um, Now for the 2D symbol, the plan symbol here, it looks kind of messy, and it doesn't look symbolic at all. It doesn't have the ceiling symbol that we would want. So what we can do for that is we come into that 2D symbol that we saved. We can go to 2D. This is really simple. It's just a few lines, some geometry, and a text parameter. I'm going to grab this whole thing here, minus the add and mul commands. I don't want this to be resizable to the size of the final object, and I don't want it to be offset from that final object. I'm going to copy this over into the 2D script here. Now there's a lot of 2D script here because it's translating every single vertice and edge of those 3D geometries into 2D. So for this, I'm just going to say Command A and then delete. And I'm going to paste in that 2D script here. So now in the 2D script, I should see, hold on, I think it's using, yeah, so we want to use a pen attribute that's correct. So let's use pen attribute 3. Under the 2D script where it says pen attribute, we'll make that a pen attribute that actually has color to it. Um, Now there's other things that we can do. Maybe this P1 is not the default text I want. So here where it says P1, that can become a variable as well. So under my parameters, I'm going to add another parameter here, and we'll call this, we'll type SYMB uh, text. So that's the variable. I'm going to make this a text variable, and we'll say 2D symbol text. And let's just call this pendant for now. So I want this to be tied to this. So I'm going to copy this symbol text, and I'm going to replace this P1 with symbol text as the variable. And now that symbol text parameter is whatever I want. So I can change this back to P1 now. And that becomes P1 or whatever I decide to put in here. So it's become a flexible, versatile thing. If I delete that, then it eliminates the text. Um, I can create options for whether or not this thing is going to be symbolic or projected. There might be reasons to have like the original, like actually show the chandelier size. To do that, we're going to create another variable. This will be a text parameter, and we'll call this SYMBTYP, so symbol type. And here I'm going to copy this and go to the parameter interface here. So the parameter script. And here I type values, put in the parameter, and usually parameters don't go in quotes. I can't tell you why for the values parameter it does. But here we're just going to say what variables do we want for that dropdown. So we're going to say it's going to be either symbolic, comma, or projected. Okay. So here under the so it's the values is the GDL script. Symbol type is the variable that I put in here, and now I get this dropout that's pulling from those parameter values, symbol or projected. Now I want to apply this to my 2D script. So I'm going to say 2D, and here I'm going to create another if then. So I say if this symbol type equals symbolic, then we're going to do this. And then down at the bottom, I can type else. And then really simply an easy way to do a 3D projection of a 2D thing, we can type the script project 2, comma, or sorry, project 2, 3, comma, 270, comma, 2. And then down at the bottom, we're going to put end if. So now I should be able to switch this to projected and see that 3D projection. Let's do one
What
more
do
thing here.
the what do those numbers stand for? The 3, 270.
So the 3 is the status quo code. If I change this to like 4, for example, it's going to change it to an elevation view. 5 is going to change it to a reverse elevation view. 6 is going to be an axon view. So 3 is the status code for floor plan projection. 270 is the rotation, and it's been explained to me why it's 270 and not 0 or 90 or 180, and I can't remember what it is. I just know that if this is your floor plan and that's your X and Y axis, 270 is the rotation that you need for it to be the overtop projection.
Mm-hmm.
And then the number 2 is the appearance. So if I change that to 3, it shows shaded. If I change it to 4, it shows some other, I think, wireframe. 5, it shows full bleed. 6, yeah. So 2 is the standard for overhead solid.
Okay, got it.
Um, Okay, so we've got a custom text, we've got a custom symbol option. We can set the defaults for these to be whatever they need to be, projected or symbolic. Any questions on any of that? Okay. Um,
If we if we wanted the J box to be like a jelly, is there a way to set it to have a surface of its own?
Yeah, so if we say, let's go to the material types here. Right now, everything's the same material. Let's go ahead and add an attribute here. Now, the default is to create these attributes called pen attribute one, pen attribute two, material attribute one, material. We're going to leave that. But for simplicity, let's say JBox. Oh, we can't have special characters. So we'll call it uh, JBox mat. Okay, and we're going to copy that variable. And we're going to make sure that this is a surface attribute. Let's make sure that the junction box is on so we can see it right away. And then let's go ahead and make this red jelly. Okay. So now I have a variable. I'm going to copy that JBox material. I'm going to come into the 3D script. So I know my JBox sits here. So I'm going to look for the material parameters, not the, there's building materials and materials. Technically, materials are surfaces. We used to not have building materials, so we just had materials. And because materials go back like 25 plus years in GDL, they couldn't rename materials to surfaces without like basically screwing up every object that had ever been built. So it is important to distinguish between building materials and materials. But in here, I'm just looking for the material code. So it's building material, building material, building material. Where is my materials? Section, pen. Oh, here we go. Material attribute one. So we're just going to replace material attribute one here with um, JBox material. That's a building material, so we don't want to change that. Let's make sure we got them all. There's a couple more here. Material attribute and material attribute. Let's hit check script. Check script shows okay. If we check the 3D, now that's a red jelly up there. Unfortunately, you will have to kind of parse together these attributes. Because they're all being saved individually, it's going to default to everything as material attribute one, material attribute three for each of the individual objects that we're combining. So unless all of them have the same number of attributes, and even then it might decide that like white is going to become red and red is going to become black when you combine these objects together. So
Is each material attribute just a face of like a geometry? Is that why it's generated?
the material attribute is the surface that's being applied to that geometry. So it's describing here, it's like revolved shell is this description of materials that's revolved around 360 degrees with this shape. So it's just saying that this is creating the shell, and these are the attributes that get applied to that shell. Basically, it's describing surface, surface, cut, fill, cut, fill, cut, fill, surface, surface. I don't know why it puts them in a certain order, but you're just trying to hunt down and same with like line types and pen types. If certain things are not showing correctly, as long as you've made these notes and you know that this is everything here is my junction box. So if I see my junction box is showing with a wrong pen, for example, I could say this needs to become pen attribute 5 or 4 or 3. Just look at the parameter list here and see pen attribute 3 is the one that's using my electrical pen. So if I'm missing a pen in any of the geometry here, I'm just going to apply that. Okay.
If we had saved, like, if we had started with the junction box already being a jelly surface, is that a way to avoid this step?
No, because it's still going to save it as material attribute one. So it doesn't
Okay.
recognize that that was red jelly, or sorry, that's pen. But yeah, it doesn't recognize that that's red jelly. It recognizes that it's pen at or material attribute one. And when you copy that over,
Mhm.
material attribute one becomes massing foam core or white or whatever.
Okay.
Okay. So that's one object with adjustable parameters on those, sort of being able to resize this and change the hanging height and create all these custom symbols. I'm
I
going
have
to go
two
ahead.
questions, Patrick.
Yeah.
So for the symbol, if it's, when you see it in plan, is that going to automatically scale to the plan itself, or
For the
do you have
projected
to?
view, yes, because that project to, so for example, if we come into the parameters here and let's just make it oblong. So if it's 3 by 5, it distorts with that because it's the actual projection.
But for the symbol itself, the 2D symbol, if you have it on a quarter-inch plan and then you size it up to, I don't know, a little enlarged plan, is that symbol going to scale
The
up and
size
down?
of that symbol is it's like a wall is 6 inches thick, regardless of the scale of the plan.
Mhm.
This symbol, I believe, is a fixed size. I don't think it sizes up and down like that.
Got it. And then the other question, I know that it's probably going to add complexity here, but if you have a sloped ceiling, is there a way? What is that script that you would need to add to angle with the slope of the ceiling for
Yeah.
the plate in the J box?
We're going to take a look at one more object here,
Yeah.
a monopoint object, and that will have some rotation commands that we can look at.
Okay.
I mean, there are ways you can technically do the trig and get it to be like put in like a 3 and 12 ceiling and have it rotate to that angle. Um, I don't want to get into the weeds on that today because that's me spending an hour and a half troubleshooting. Um, I've done it before, and the reality is like you can go to the roof settings and say what is that in degrees, and then punch that into the object. I know it's less convenient, but that's going to be my recommendation for today. Okay, so I'm going to go ahead and
Also,
save. Go ahead.
also on that topic, with the projected kind of 2D representation of the 3D object, sometimes the projected symbol is a bit more messy and not how we would want it represented. Like it's showing lines of the curves or something. Is there a way you can assign like a specific 2D image that could be rescaled?
Yeah, so one thing that you can do there, let me go to, let's see, this is the pendant one. Let's just verify that this actually even works. Oh, there's another thing that we can do with this. Let's go Command Option O. Let's go to our 2D script and let's add a hotspot. So if we go hotspot to 0, 0. Um, if you wanted the 2D symbol to be cleaner or have more control over that, we can basically replace this projected view with a fragment 2 command. So if we go to our 2D symbol, 2D view, oh, wait, we have to switch it over to the projected view first. And now if we go to our 2D view, it's going to give that 2D projection. We hit Command A, Command C, and then we can go to our 2D symbol and Command V, original location, right? So that gives you lines and fills that you can then basically refine, draft, clean up. If you do go this route, you then have to go back to the 2D script and replace this project 2 with a fragment command. What is the fragment command? Hold on just a second. Let me pull that up here.
Is it all
I think it's
comma
all
zero
comma, yeah, all comma 0.
or
Well, let's just check that. All comma 0 and then
and
check
then
script. Yeah. So then instead of using the 2D view, it's going to have whatever. Oh, sorry, I went to the wrong one. Yeah, it's going to have whatever I put here. So if I start cleaning a bunch of this stuff up, right? And now my 2D symbol looks like that instead. The other thing that I usually like to do that I skimmed over is if we go back to the symbolic view, and then the 2D script, I also like to use that project to command just to verify that that is lining up, that the 2D symbol and the 3D symbol are lined up. Um, it's easy to like save it from the wrong spot or realize that it's or not realize that it's like scaling differently or whatever. So that project 2 can be a useful kind of check just to make sure that it's lined up. Yeah, this fragment 2 command can be a way to get more control over the level of detail. Um, And I believe that it does still scale with the object, with the AB, or yeah, the AB, the XY parameters.
Yeah.
I don't know, let's test that. So if I go to projected and make this 6 feet wide. Oh, I guess it doesn't. Interesting. So that would be the downside to using the fragment 2 command as opposed to the project 2. But you could also try some of those like status codes. So if we went project 2, 3, 270, comma 2, right? So there's that. And then, but if we go to say status code 3, does that clean it up any better? Nope, that's 4. Nope, that's a little bit cleaner. I think that that might be like view from underneath or something like that. Anyway, okay. Let's take a look at a different fixture here, that monopoint fixture. So I have that modeled here. Let's go ahead and do the same thing we did last time. We're going to snap a screenshot of this thing as our preview. Let's check out what we have modeled here. Right, so I have a few different shells on here. I have 3 shells for the main light housing. I have 1 shell for the ceiling fixture that includes that sort of reveal. So really all of this stuff needs to be saved from this point because that's going to be flush with the ceiling. And then the junction box sits here. And all of these are just revolved shells. So let's grab this stuff and move it into place. We did before. Where's my 0, 0? Oh. Okay, so in plan view, I'm going to get this lined up here, isolate it to 3D, figure out where the Z axis needs to go. We'll get it close. Okay. I don't feel like that was it. Well, that's at the right height now. Let's just double check our floor plan because I think it's shifted to the edge. And it really doesn't matter as long as they're all from the same origin, but having it centered up just makes it that much easier because I know where I'm rotating from. Okay, so here, that's the junction box. We'll pull that off the side 3 feet. Probably 3 feet might have been too much. So we'll put that there. And then just so I make sure that I'm grabbing the right one, because I have 4 shells all stacked over the top of each other. So this is the actual hanging piece. So we'll pull that over 1.5 feet. So that's that piece. All right, so here's my main fixture, the housing. And I know that this actually does sit below the 0, 0 point. It's sort of fixed according to the spec sheet. It's fixed at like 6 inches below or whatever that height was. Um, I think that it's probably we're gonna go ahead and move that up because I wanna have control over those modifiers in the actual script. Let's go back into our floor plan view. We're gonna grab this and we're gonna go to File, Libraries and Objects, Save Selection as Object. We'll create a new folder and we'll call this the monopoint light. And again, change details and set preview. And I can grab that as my fixture, say OK, and place that object. Right, and now I'm going to move this out of the way. And we're going to save this piece. So that'll be File, Libraries and Objects, Save Selection as Object. I'll put it in the same folder. Call it whatever we need to call it, and we'll place that object. And then lastly, we're going to save this box. And Anita, this will kind of showcase that point that this box is going to become whatever material that we copy and paste it in, but we're going to change that after the fact. Um, so we'll go File, Libraries and Objects, Save Selection As, JBox 3 or 2 or whatever. It doesn't really matter. We just need to have it with a unique name. And we'll place that one. And then we'll grab all three of those and open them up. Command Option O is the shortcut to open an object. Or it's File, Libraries and Objects, Open Selected Object. Okay, so there's the junction box, the monopoint, and the monopoint fixture. Okay. Now, under the parameters list here, we want to have a parameter for the position of this monopoint. And we can have like X and Y rotations, but let's kind of keep it simple for now. So we're going to add a couple of rotation commands here because this, like to Anthony's point, this might be in a sloped ceiling. So we want the whole thing to be able to rotate, but then we also want the monopoint to be able to rotate independently of that. Okay. So let's actually create like three different rotations so that way it can rotate to the ceiling X or Y. So let's say CLR X. So that's ceiling rotation X. And this will be an angle command. And I'm going to create two more and we'll call it CLRY. And we'll call the third one MPR. So that's the monopoint rotation. And all three of these are going to be rotation commands. So this is going to be ceiling slope X, ceiling slope Y, and mono point angle. Okay, we'll focus on this one for right now. So we're going to copy that MPR, and we'll go into the 3D script here, and we'll say ROTX, rotate X is the script, and then I'm going to paste in MPR. Now let's take a look at that script here. And if we look at the parameters of this, we should see this, if we say 22 degrees, for example, we should see that rotate, right? So now I have a rotatable monopoint. There are ways that we can also put like hard stops. We can like create a script that says if MPR is greater than 90 degrees, then MPR equals 80 degrees. So it won't, if somebody types in 110 degrees, it's not going to flip completely upside down. That's pretty simple to do. If I copy this and I go to my master script, I can say if MPR is greater than 90, then MPR equals 88, else, and if. So just to, as a proof of concept now, let's go back to the 3D view. So if this says 110 degrees, right? It's actually going to be that 88 degrees. Or I could even like we could even say that it's a hard stop at like 45. Right? So now it's 45 degrees even though I've put in 110 degrees. So some simple like hard stops on some of this stuff can be helpful. Okay, so we've got the first part of this in here. Let's combine the ceiling box to this. So the other thing about this is that I know that this whole thing's going to shift down. So we'll say add Z negative, I think it was -6 inches, but we'll say -5 inches for now. And we're not going to see anything here because it's not adjusted yet. There's nothing to reference it to. So we'll put a comment in here and we'll say mono point housing and we'll paste in the mono point base. So if we go to the monopoint piece right here and go to our 3D script, again, we're going to get rid of the add and the mul commands here and get rid of the comments at the top. There's a really simple rotation. So we're going to grab this whole script and we're going to copy it and we'll come back into this one. Oh, we also have to get rid of the add commands here. We can keep the mul commands if they're of interest, if you want to be able to resize the housing. If you needed to resize the housing and the base, you would have to create additional parameters for those sizes. Anyway, so now we should see, why is that there? Did I not? Maybe I didn't make it tall enough. Hmm. Or maybe I have my rotation, my add commands backwards. Order of operations does matter. Nope, that's not it. I bet I just didn't make that stem long enough. Yeah, that's what's going on. But it is rotating off of the center of that housing piece. So that housing is just not tall enough for the stem. So I would have to go back and resave that with a taller stem in order for that to be effective. But the add commands are all gone, so that should be okay. Um, so we're good here. So now let's put in the junction box. Um, okay, so we'll come into the J
We could have
box.
done the same thing over here that we did in the pendant, where we added the cylinder into the script to make the
That's
height
true. Yeah,
adjustable.
if you wanted the height to be adjustable. On this one, when I was looking at the cut sheet, it gave like a fixed height of that. But yes, if you wanted a
Hmm.
parameter, you could have that parameter as a cylinder with an adjustable stem height.
Okay.
You
Yeah,
just
I
make
think
sure that
in
you save that out as its own separate thing, or don't save it out, eliminate it from and put it in as its own script.
okay, good.
Yep. We'll get rid of the add and the mul commands here. We're going to grab this whole thing and copy it. And in here, we're going to paste that into here. And then we see that junction box. So now that junction box, we want that to be red jelly. So go to our parameters list and we'll add a surface here. JBox surface, copy that variable, make it a surface. Right, and we'll make this red jelly as well. And then we just have to fish out the material attribute here. So on the junction box, we don't want to use material attribute 1. We want to use the junction box surface that we created. Again, making sure that I'm only pasting it over the top of the material, not the building material. Okay. So now looking there, we've got that as a red jelly. We could do the same thing we did before. If that junction box needs to have an on-off command, we can say new JBox on off. We'll copy that. So the variable, what you name those, it just has to start with a letter. It can't start with a number, and it can't have any special characters. I believe that even includes dashes. It's okay with underscores, but not dashes. And again, we'll make that a Boolean function, and we'll say JBox on off. And in the 3D script, we'll say if JBox equals 1, then we're going to do this stuff. At the end, to end that if statement, we say else and if. And because it's 0 by default, it's going to be off by default. Now that junction box sits above this. So when I say, if I come into the 3D script here and say hotspot 0, 0, 0, that's putting a hotspot right at the ceiling. So when I snap this in, it's going to snap to the ceiling. So let's go ahead and save this. Come to the first floor here, and we will. So there's my monopoint light. If we look at that in 3D now, so the hotspot sits right here. If I don't want to see any other hotspots, we can do that as well. We can say um, under the details, we can go to compatibility options and uncheck this hotspot at bounding box. And now when I go file, save, um, in the 3D view, oh, it still has those bounding box points. Those should be gone. I don't know why those are still there. Um, well, I don't want to drag on too long trying to troubleshoot mundane things like that. The other thing is we might have the ceiling rotation, right? So if I want to rotate everything all together, the rotate command right now is just at the monopoint piece, right? So I have the add rotate command here. Um, I can have a rotate command on top of a rotate command. So like we were looking at before, if I say CLRX, I'm going to copy that and say rotate X and rotate Y. Check script is okay. If I go into the parameters now, and let's say it's a 22-degree slope on the ceiling, I now have a monopoint light that will rotate. Um, yeah, if it rotates the other way, we can do that here as well. Oh, right. Okay. Hopefully this was helpful.
Super helpful.
I think it was
Okay.
helpful.
Yeah,
Would you
great to
recommend
see.
would you recommend building the objects in a ELN so that you're not cluttering your
Um,
folders?
that's one of the reasons that in the library manager, I create um, those working object folders. In fact, there is a
Mhm.
process folder in here already, so you could dump stuff in there. And then when you get the final object done, you just go save as. So I didn't name them the specific manufacturer or anything, but then I'm going to go save as, put it in the electrical folder, and say that this is whatever brand name monopoint. Right? So that gets saved there, and then the object that I used to build it from, or the objects that I used to build it from, I can just blow those out of the process folder later. In fact, I think it's probably better to build them live in your working folder because then you know that the surfaces that you're pulling from are the surfaces you have in that file.
Mhm.
Technically speaking, you could go File, New, and launch use the latest project settings, launch a new instance. That should give you the core attributes that you have in your working file. Um, but ultimately, in the end, you're going to want it in this file. So building it out in the file, I think is fine. One thing that I actually picked up recently that I hadn't thought of is, and I'm going to build this into the template pretty soon, but using a design option for these sort of basic primitive elements for like the shells and the morphs and the meshes and beams and columns that you model these fixtures with and save as an object later. Putting those on their own dedicated design option means that they can all kind of hang out at the 0, 0 point and not clutter up your model because they're always going to be off. You would have to
Mhm.
literally like force them to go into the design option combinations and turn them on. But as of right now, it's on that temp hide layer. So that's
So
that.
you would keep all of those components in 3D.
I think it's worth it to have those the basic elements. Oh, another thing I didn't mention before, but it's worth it also to keep tabs on the size of these things. So if you go to Window, Palettes, and Poly Count, make sure that anything custom that you're building is reasonable. So that pendant light was 3,000 polygons. Um, If I had built that out of morphs, it's very likely that it would be a lot bigger object, but it would probably be the same number of polygons. I'm not sure if I think we talked about this like way back in original training, but just to give you an idea, if we go to this stuff right here, the original shells for this, if I go actually let's do this. I'm going to copy this and convert this to morphs just as a side-by-side comparison, right? So now I go File, Libraries and Objects, save selection as object, and we'll put it here and we'll call this morph test, right? So it's the same geometry as the other pendant. It's a little bit lighter because I don't have all the 2D symbols and the add commands and stuff. But it's essentially the same core geometry. If I look at my library manager now, the morph test is 2.3 megabytes. The pendant light is 177 kilobytes. So, and the only difference was that this was modeled with morphs and this was modeled with shells. Um, and that's not to say you can't use morphs to create these custom objects. It's just that the morphs are essentially describing every single face. So if we look at, let's go ahead and look at that as well, side by side here and here. If this one is this pendant light, right? So if I open both of these up now, so the pendant here, the 3D script, even with all of those parameters, is 720 lines of script. The morph object is probably going to be like 7,000 lines of script, maybe more. Nope, still counting. So that's why that object is so big, because it's defining every single edge, every single face. Yeah, I'm 21,000 lines of script for the same geometry using morphs as opposed to shells. Um, Another thing that's useful for creating these objects is in the object tool itself, there are these basic shapes. These can be really useful, like the cones and like ellipsoids and tubes and stuff. I use a lot of these elbows and tubes for like plumbing fixtures. The thing about those is you do have to convert those to morphs because you don't want to save an object into an object. It saves as a macro. And if Graphisoft ever decides to discontinue elbow or dome, your object's broken. So that's sort of like it, as bad as it can be for file size to use morphs, if you're going to build it with things like these basic shapes, um, uh, you do have to convert them to morphs. Technically speaking, I believe if you really wanted to get into the weeds, you could open these objects and look at how they're scripted, and try to rebuild them, but I don't know if it's worth that. Okay,
Great.
any
Thank you.
questions?
No.
All right. Well, I don't know if this was recording to your computer or to mine, Richie. But if it's yours, then we'll get it uploaded and shared so people can kind of reference it, and you guys can kind of scrub back through it if you need to reference anything mentioned.
Okay, sounds good.
That was
Thanks
helpful.
for that.
All right, guys, have a great weekend.
Thank you,
Thanks, you
guys.
too.
Bye.
You guys too.